So hello everyone, welcome back to my channel. In today's video, we are going to break down one of the most important concept for matrix updated, the 2D difference array technique. So this method is extremely useful for competitive programming, interview preparation, and problem where you need to update large submatrix multiple times. Okay, so sit back, relax, and let's go deep into the logic step by step. So here problem is we are given a number n which define an n into n matrices. This matrix is initially filled with 0. We are also given a multiple queries. Each query represents a rectangular region inside the matrix. A query looks like row 1, column 1, row 2, column 2. Okay, that means start at row 1, column 1 and end at row 2, column 2. Okay, add plus 1 to every element inside the submatrix. Okay, so here we have just a start with the brute force method, but it fails. Reason is that if we try to update every cell individually for each query, we need to run a huge time complexity problem. Okay, so like we have just calculated that maximum matrix size is 500 into 500, that is equal to 2,50,000 cell, and maximum query is like 10,000. Okay, sorry. So worst case operation is what? 2,50,000 into 10,000, that is 2.5 billion update. So phones, laptop, even high-end system can't process this fast enough. Therefore, brute force method time limit exit reach. Okay. So we need a smarter approach. That is, we have just to go with 2D difference array. That is, it helps us to mark how value changes instead of updating each cell immediately. Think of it like this: like instead of pouring water into every glass by one, we only mark where the water starts flowing and where it stops. Then at the end, we calculate the real value using prefix sum. So logical breakdown of the difference array: what? A difference array allow you to update a full range in constant time by doing a few boundary operation. Like for a 1D, if you want to add plus 1 from index L to R, you do like diff I is equal to plus 1 is equal to 1, and diff R plus 1 minus is equal to 1. Okay. So then prefix sum reconstruct the actual update array. So we are doing the same idea but in 2D. So how to update a sum matrix in 0, 1? Important question is that. So for each query R1 C1 to R2 C2, we apply 4 operation. Here we have seen diff R1 C1 plus 1 is equal to 1, diff R1 C2 plus 1 minus is equal to 1, diff R2 plus 1 C1 minus is equal to 1, and diff R2 plus 1 C2 plus 1 plus is equal to 1. Okay. So let's understand this line deeply. Diff R1 C1 plus is equal to 1, that means it means like start increasing value from the cell onward. This marks the beginning of the increment. Second point is diff R1 C2 plus 1. So diff R1 C2 plus 1 minus is equal to 1, that means it marks where the increment should stop horizontally. After column C2, we should not increment further in that row. Diff R2 plus 1 C1 minus is equal to 1, that is means it marks where the increment should stop vertically. After row 2, we should not increment further in that column. Also diff R2 plus 1 C2 plus 1 plus is equal to 1. This is a correction step here because the previous two minus operation overlap and subtract twice. We add back that value once. This maintains the correct increment result. So the prefix sum phase, that is a deep logic. Here is like once all queries are proceed, the difference matrix container marker, not actual value. So basically to convert this marker into real value, we have done the like row wise prefix sum, column wise prefix sum. Okay, so at the end of this two step prefix sum, every cell now contain like total number of queries like affecting it and correct addition from overlapping rectangles. So final also like final actual results. So we will just look at that line by line. So here line in the line 1, like we have just created a like we create a matrix of size n plus 1 into n plus 1 into n plus 1. Okay, so that while applying update, we can safely mark boundaries without going out of the range. Like line number 6, R1 C1 R2 C1 in query, like we iterate through every query and apply our 4 boundary update method. Also in line like diff R1 C1 plus 1 is equal to 1, that is tells the matrix start increasing value from here. Also like diff R1 C2 plus 1 minus is equal to 1, that is say like a stop increasing after column 2. Okay, also in the like diff R2 plus 1 C1 minus is equal to 1, it says like a stop increasing after row 2. Okay, so also like in the last that is diff R2 plus 1 C2 plus C2 plus 1 plus is equal to 1, that means it correct the data extra subtraction that happens due to the boundary. Okay, so in the line number so in the like row wise row wise means a prefix in the either I in the range, that is diff I j plus 1 plus is equal to diff I j in the line number 15. Okay, so this is split the increment horizontally across each row. Okay, like in we have talking about like column wise also too. Here we have just taken that the for j in the range n, for I in the range n, diff I plus 1 j plus is equal to diff I j. Okay, this is split increment vertically down each column. In the final matrix, okay, like return row n and whatever not. Okay, we take only the first n row and n column, discarding the extra boundary row by column. So the final result was what? The resulting matrix now correctly show how many queries affect each cell. So from these questions, the conclusion is what? It tells the like direct brute force is not always the way. A smart mathematical technique like difference array can reduce complexity problem. Okay, what was the earlier impossible due to the billions of operation becomes easy with just 0 n square plus queries time. Okay, this technique widely used in like commutative programming, range update problem, and image processing. Okay, so always remember that when we need to update many submatrix or some array, think about difference array first. Okay, so basically that's from my side and the complete explanation of the solution. So if you enjoyed this details breakdown, make sure to like this video, subscribe to the channel, and comment which problem I should explain the next.